All right, moving on to geometric proofs. Last section we spent a lot of time solving algebraic equations and proving each step. Now we're going to solve some angles, solve some segments, and provide a geometric reason for each of those steps. So if you remember, when writing a proof, it's important that we justify each logical step with a reason, okay? That's why those two column proofs, you have statements and reasons. Every one of those statements or every one of those steps needs a logical reason that goes with each. Most of the time we can use symbols and abbreviations in your reasoning, but it must be clear enough so anyone who reads the proof, like myself or a classmate, can understand. Reasons can come in the form of multiple things. So I'm going to give you guys a sheet that has the reasons to be used in proofs. In class today, I want you're going to get the same sheet on the test, but there's going to be a set of definitions that we've already talked about this year, postulates, properties, and theorems. And on this sheet, it's going to include every definition, postulate, property, and theorem that we've defined this year. So a couple examples of each of these. Definitions, we've talked about the definition of supplementary angles. Like I said, you can abbreviate and use symbols if you'd like, but the definition of supplementary angles states that two angles that are supplementary, their angle measures sum to 180. Postulates, segment addition postulate is just one example of different postulates we've used this year. We're going to be using that in an example down below. Properties. You used a lot of properties of equality on the previous lesson. Subtraction, addition, property of equality when you're solving equations. Again, you can abbreviate and use symbols. And then theorems. Theorems is really what we're going to focus on today because we haven't listed out too many theorems. We've just stated what these theorems are, so we're going to use them in proofs today. But the linear pair theorem is an example of a theorem we might use in a proof. Right? And if you remember a linear pair, we defined what a linear pair is: two angles that are adjacent and form a straight line, like 1 and 2. Well, the linear pair theorem states that if 1 and 2 are a linear pair, they must also be supplementary, meaning summing to 180. And you're going to have those theorems listed on the back page of these notes, okay? So we'll get to theorems in just a sec. But let's continue with writing our two-column proofs. Now I'm gonna make it a little bit more formal for you, so you have it's nice and organized. The statements are going to be given, so you kind of have an idea of where to start. But we always want to first ask what's given and what are we trying to prove. So the last statement is what we're always trying to prove. We're trying to prove that the measure of angle PQR is 135 degrees. So all the statements here are provided. We're just filling in a reason, and remember, it needs to be a definition, postulate, property, or theorem that justifies each step. And remember, some of this stuff is going to be given, like this first step. PQR and MNO are supplementary. We are told that to begin this problem, so it's given. We are also told that the measure of angle MNO is 45 degrees. That is also given. Okay, then we are told that the measure of angle PQR and the measure of angle MNO equals 180 degrees. Well, if they are supplementary angles, then we know that their two measures sum to 180. So that would be the definition of supplementary angles. You can abbreviate and use symbols. Okay, great. We are also told that the measure of angle MNO is 45 degrees. So we could take 45 degrees and plug it into any equation where we see the measure of angle MNO, which is right below, and that would be using the substitution property of equality. And then your last step, if you're trying to show that the measure of angle PQR is 135 degrees, you're just subtracting that 45 degrees over to both sides, which would be the subtraction property of equality, which you used a bunch on the previous night's homework when you were solving algebraic proofs. Okay, great. Why don't you guys try B? Again, for B, you're trying to prove that segment BC is congruent to segment EF. That's your last statement that you're always trying to prove. And we can fill in two given statements, right? Let's go fill in our givens. B is the midpoint of AC. That's something you are told to begin this problem. And AB is congruent to EF. That would be down here, another given statement. So why don't you go fill in those next two reasons. We'll check your answers when you're done. Okay, if B is the midpoint of AC, then AB has to be congruent to BC because a midpoint means it splits a segment right in half. So this would be your definition of a midpoint. Awesome. For 4, BC is congruent to EF. Well, this is a property that we introduced last lesson. If AB is congruent to BC and AB is also congruent to EF, then what must be true about these two segments? Because that's 3 different segments being congruent to each other. BC must be congruent to EF because of the transitive property of, and this would be congruence because we're talking about congruent segments. Not equal lengths just yet. Although if they're congruent segments, they're gonna have equal lengths. Right now we're just stating that they are congruent. Okay, moving on, we're gonna try our full 2-column proof on the back of this page. Just remember, theorems. A theorem is any statement that you can prove. Postulate is a statement that we cannot prove, we just assume to be true. But instead of going to prove all of these theorems, we're just going to do a quick sketch to show that these are true. All right, so we have a couple on the back here. Linear pair theorem, let's write them all out. 1, 2, 3, 4, 5, and 6. We're going to list these all out. And most of these terms in here are words we've heard before. So linear pair theorem, we introduced this on the previous page. The linear pair theorem states that if 2 angles form a linear pair, like angles 1 and 2, angle 1 and angle 2, then angle 1 and angle 2 must be supplementary. So the measure of angle 1 plus the measure of angle 2 would equal 180 degrees. Okay. For congruent supplements theorem, the congruent supplements theorem states that if 2 angles are supplementary to the same angle, then those 2 angles have to be congruent. So say we have an angle, oops. Okay, say we have angle 1, and angle 1 is 110 degrees, and then we have angle 2, and angle 2 is 70 degrees. Well, if we have another angle that's also supplementary to 1, like angle 3, then angle 3 would also have to be 70 degrees. So we could state that 2 and 3 must be congruent. because they're supplementary to the same angle. Angle 2 is congruent to angle 3. And you can see that clearly right here, 70 and 70. Right? I'm going to skip ahead to 4 because 4 states the same thing but for complementary angles. So if we have two angles that are complementary to the same angle, those two angles must be congruent. Let's draw another example down here. Say we have angle, let's label it. We have angle A is 30 degrees. Okay. If angle A is 30 degrees and angle B is 60 degrees, and these two angles, angle A and B, they're definitely complementary. Well, if there's another angle that's complementary to A, like C, it would also have to be 60 degrees because 60 plus 30 gets us 90. So then what would be true about those two angles that are complement to the same angle? They would definitely be congruent, so we would say angle B is congruent to angle C. Congruent complements theorem. The right angle congruence theorem, pretty simple. If you have two right angles, those two angles are congruent because they both equal 90 degrees. Okay, I don't think we need a drawing there. Let's talk about our vertical angles theorem. And really this is, well, we can list out our last theorem here. For vertical angles theorem, if we have two vertical angles, they're always congruent. Okay, this can be proved with this theorem can be proved with a proof, but we're not going to. Angle 1 and angle 2, they're always going to be congruent to each other. Okay, 3 and 4 would also be congruent as well. And then our last theorem just states if two congruent angles are supplementary, then each angle is a right angle. Right? There's only, if I had two congruent angles that were supplementary, the only measures that they could have would be 90, because 90 plus 90 gets you 180, and 90 is congruent to 90. 90 plus 90 equals 180. Okay. So a quick review of some theorems we've already talked about, some that might have been introduced to you today, but that's fine. But we've definitely already covered linear pairs, vertical angles, and right angles. So maybe just the congruent complements and congruent supplements was new for you today. Okay, we're going to finish with two more proofs. Now everything's missing here. So we're trying to prove something, we're given some information, and we either need to fill in a statement or a reason. Okay. So if you look at A, we're given angle 1 and angle 2 are supplementary, and we're trying to prove that angle 1 is congruent to angle 3. Or sorry, angle 1 is congruent to angle 3. We're trying to prove that 3 and 2 are supplementary. So let's fill in some information here. Maybe you want to draw this out, and it might be obvious, that's okay. But if we have two supplementary angles, angle 1, let's just call 120. Angle 2, let's call 60, because supplementary angles add to 180. So let's call this angle 1, angle 2. And then if we know that 1 and 3 are congruent, well, then 3 would also have to have a measure of 120. Okay. We're trying to prove that 3 is congruent to 2. And it might be obvious, or we're trying to prove that 3 and 2 are supplementary. It might be obvious in here you could see, oh, 3 and 2, 60 and 120, those are supplementary. That's okay, we want to put out a two-column proof and list every single statement with a justified reason. So let's fill in our givens. Angle 1 and angle 2 are supplementary. And then we are also told that angle 1 is congruent to angle 3. Well, if 1 and 2 are supplementary, then we can state that their two measures sum to 180 degrees because of the definition of supplementary angles. Now we know that the measure of angle 1 is going to equal the measure of angle 3 because they are congruent, right? Congruent angles means their measures are the same, so this would be the definition of congruent angles. And now because their two measures are equal, we can take the measure of angle 3 and substitute it in anywhere you see the measure of angle 1 because they're of equal value. That would be the substitution property of equality. Awesome. And now we were trying to prove that 3 and 2 are supplementary, which is what we just did right here, stating that their two measures add up to 180. We can now say that 3 and 2 are supplementary. Even though you might have just been able to see that by drawing that illustration out and showing up there, it's nice to have this formal two-column proof using substitution, showing that congruent angles have equal measures, and completing that proof. All right, let's finish with B. You're told that the measure of angle ABC is 90 degrees, so we're told that this is a 90-degree angle. We're told that the measure of angle 1 equals 4 times the measure of angle 2, and we want to prove that the measure of angle 2 equals 18 degrees. Once again, I'm going to get you started with your given statements. So this right angle is a given statement, ABC. And then your second given statement would be the measure of angle 1 equals 4 times the measure of angle 2. Okay, why don't you go ahead and fill in what's missing here, and then we'll check your work when you're done. Okay, for 3, 1 plus 2 equals the whole angle. This was your angle addition postulate. Remember, use the diagram if it's given. Might help you see what reason is going to justify that step. Then the 4 times the measure of 2 plus the measure of 2 equals 90 degrees. Well, all we did here was, if we know that the measure of angle 1 is 4 times the measure of angle 2, we can just substitute that in. So this would be the substitution property of equality. Okay. Combining like terms. Remember, we talked about this step in our previous lesson. It's the same as just simplifying an equation, right? And you could simplify 4 times the measure of angle 2 and the measure of angle 2. It's like simplifying 4x plus x, right? We get 5 times the measure of angle 2 equals 90 degrees. And then if we're trying to prove that the measure of angle 2 is 18 degrees, we're going to get there by dividing the 5 to both sides, and we get the measure of angle 2 equals 18 degrees, with a reason for each. Okay, so once again, I will get you a sheet that has every definition, postulate, property, and theorem that we've used so far this year, so you can have those reasons that you're going to use on proofs nearby. I'll get those to you in class, use them on the homework, and you're going to be allowed to use it on the quiz, okay? So I'll go over with you in class how you're going to practice using that sheet and completing these two-column proofs. All right, good luck on the homework. Keep it neat. Go ahead and you can copy and paste a statement and reason two-column proof from Google if you need it. I'll answer any questions you have in class.